These 3 pounds of tissue are your entire life, and it contains many localized areas, each responsible for different tasks. For example, this is where you make judgments, here is where you process your sense of touch, this part farthest from the eyes is where your vision is processed, and this is what's allowing you to listen to this video. But the sections I'm going to talk about are the 2 hemispheres. Have you ever heard someone tell an artist they're right-brained and a scientist they're left-brained? This is referring to the 2 hemispheres of the cerebral cortex, the right hemisphere and the left hemisphere. While these people are right, creating a drawing mostly uses the right hemisphere and analyzing scientific data mostly uses the left, the 2 hemispheres are constantly working together and interacting with each other seamlessly. Neurologists discovered that the 2 hemispheres interact by literally taking them apart. In 1961, Philip Vogel and Joseph Bogan surgically severed the 2 hemispheres by cutting the corpus callosum, which is the band of neural fibers that connects the 2 hemispheres. When studying these split-brain patients, neuroscientists found something pretty odd. Both the left and right hemispheres were functioning properly on their own, but the 2 sides were no longer communicating. How did they find this out? The split-brain patients were told to stare at a dot on a screen, and while staring at the dot, the word heart flashed on the screen, with the dot between the E and the A. When asked to say the word they saw, the patients responded art. But when they were asked to point to the word with their left hand, they pointed to he. Why? Well, first we have to understand that the brain has a fun little party trick. The right hemisphere controls the left side of the body, and the left hemisphere controls the right side. So, the left hemisphere processed art through the right eye, and the right hemisphere processed he through the left eye. In an undivided brain, the 2 hemispheres would put this information together to interpret the word heart. But when the corpus callosum was severed, the 2 hemispheres were no longer able to communicate. Because speaking is processed in the left hemisphere, when asked to say the answer, the patient's left hemisphere answered. But when asked to use their left hand, their right hemisphere answered. So if our 2 hemispheres can function on their own, why do they have to communicate? To answer this, let's look at day-to-day language. When someone says, "No, don't go getting a big head," your left hemisphere processes the words they say, but your right hemisphere interprets this to mean, "Don't give in to your ego." When someone asks you an obvious question, your left hemisphere determines the answer, but your right hemisphere decides to answer sarcastically. So while our hemispheres could work independently, when they communicate with one another, we can better interpret, understand, and relate to the people around us.